Hi student, welcome to chemistry class with Emerald. This video is brought to you by Agota Virtual Learning, and in this video we are going to be looking at period 3 and 4 methods. Period 3 and 4 methods, especially when it comes to their oxides, their trioxocarbonates, and their reactions with acids. Let's start with the period 3 elements. The period 3 elements are able to react with water. When they react with water, for instance, in period 3 we have sodium, magnesium, aluminum, silicon, phosphorus, sulfur, and the likes. But our focus is on the methods of period 3 and period 4. So specifically we are going to be looking at sodium, magnesium, aluminium, silicon, phosphor, aluminium, then potassium and calcium. However, we're also going to be looking at some other elements of the period 3. Okay, so let's look at when sodium reacts with water, for instance, it reacts vigorously to produce sodium hydroxide and hydrogen. Potassium we also do the same. And then of course the same with magnesium. Magnesium will react slowly with no visible reaction, and it will produce an alkaline solution, a weakly alkaline solution. Same with calcium. So generally sodium, magnesium, potassium and calcium react with water to form a base and with the liberation of hydrogen respectively. Okay, so why is sodium and potassium react more than the magnesium and calcium? Sodium, potassium will lose one electron, magnesium lose, and calcium will lose 2 electrons. Of course, we know that it takes less energy to remove 1 electron than 2. So therefore, more energy or heat is usually required for magnesium or calcium to react. And of course, the magnesium and calcium hydroxide produced are not very soluble in water because they produce few hydroxide ions, then making them weakly alkaline when compared to sodium hydroxide or potassium hydroxide. Okay, so let's look at the period 3 element, their reaction with oxygen. Sodium reacts with oxygen to produce sodium oxide with a yellow flame. Potassium will also do the same, and it will produce a pale yellow flame. The same with magnesium. Magnesium will react to produce magnesium oxide with a white and produce a white flame. The same thing with aluminum. All of them will produce oxides respectively. Now let's look at the trends in the physical properties. Metal oxides like sodium oxide, magnesium oxide, potassium oxide, calcium oxide, and aluminum oxide. You will notice that the metal oxide have high melting points, the strong forces of attraction between each ion, and of course lots of it are required to break their bonds. The group 2 oxides, mainly magnesium and calcium oxide, they are higher than group 1 oxide, potassium and sodium oxide, because 2+ ions attract O2- ions more strongly than 1+ ions. Aluminum oxide is lower than expected because 3+ ions are small with a higher charge. So this will distort oxygen electron cloud, making the bond partially covalent. The non-metal oxide in period 3 specifically, that's the silicon, phosphorus, and sulfur. Um, we have the SiO2 as highest of the non-metals because it forms a giant macromolecular structure. The strong bonds are also required to break it. The phosphorus oxides and sulfur oxide, they are simple covalent molecules. They have weak intermolecular force. They have dipole forces and van der Waals forces respectively. The ionic oxides of potassium, sodium, magnesium, and calcium dissolve to form hydroxide. They dissolve to form hydroxide or form what is called an alkaline solution. For instance, sodium oxide would dissolve in water to form sodium hydroxide with a pH of 12 to 14, which is strongly alkaline. The same goes to potassium oxide. It will dissolve in water to form potassium hydroxide with the same relatively same pH, strongly acidic, strongly alkaline rather. Magnesium and calcium oxide will also react with water to form magnesium hydroxide and calcium hydroxide, which is also alkaline. Okay, so we have the simple covalent oxide of phosphorus and sulfur form acidic solution, as seen in this equation that we put here. The form acidic solution as seen here. Okay, so we could have sulfur 6 oxide will also react with water violently to form H2SO4 respectively. The interesting part, however, is that of aluminium oxide, which is insoluble, and it will react with acid and base to form salt. That means that aluminium oxide is amphoteric. Aluminium oxide is amphoteric. It can react with both. It is insoluble in water, and it will react with both acid and base to form salts. Okay, let's look at the pH of period 3 oxide. It's very similar to calcium and potassium in period 4. The oxides of potassium will also be acidic. And that of calcium will also be acidic as well. So we can put them as acidic. So P410 SO2 SO3 are acidic. SiO2 is neutral. Al2O3 is amphoteric. MgO and Na2O, including CaO and K2O, are alkaline, and this is their pH. This is their pH. Okay, so like we have said the other time, as remember that when acid reacts with a base, forms salt and water. The same is for period 3 oxides, including period 4 oxide, especially potassium oxide and calcium oxide. Let's look at how these oxides will react with acids respectively. Potassium, sodium or potassium oxide will react with HCl to produce sodium chloride or potassium chloride and water. Then magnesium oxide and calcium oxide will also react with H2SO4 to produce MgSO4 or CaSO4 and water. So since they are basic, since these oxides are basic, they will react with acid to form salt and water respectively. Please take note of that. Important. However, for aluminum oxide, which is amphoteric, it will react with both acid and base to form salt respectively. For instance, aluminum will react with H2SO4 to form Al2SO4, and also react with a base to form to give us a basic salt as well. Now, for silicon, phosphorus, and sulfur, they are all acidic. They are all acidic oxide, and then we react with a base to form salt and water, respectively. Um, let's look at potassium oxide in much more broader way. Potassium oxide is an ionic compound formed by combining potassium and oxygen. Um, the formula is K2O, and of course, it cannot be found free in nature because it's very active. Valency of 1. Um, it is obtained as a gray crystalline substance when potassium is oxidized, and is a strong corrosive alkali when dissolved in water. We could see the physical property of potassium oxide because it's a oxides of an element in period 4. So we are looking at it separately. So we have it's odorless, a pale yellow solid, which is soluble in ethanol and ether, and then of course it has the heat capacity there. So when we look at the potassium, the chemical properties, for instance, when you react it with water, it forms potassium hydroxide, like we have said for period 3 element as well. It's also react with hydrogen chloride to form potassium chloride and water. We have said that previous time. The same when we look at calcium oxide, it's also known as quicklime. It is white, caustic, and alkaline substance, and some of its properties include these that you are seeing there. These are some of its properties. And then when we look at some of the reactions, we will see that, like we have said the other time, it will also react with acid to form salt and water, like we have said the other time. It will react with water to give a base. It will also react with Trioxocarbonate 4 to produce a metal trioxocarbonate. Okay, so let's look at some of the reactions of period 3 and period 4 metals with acid. Generally, all of them will react with acid to form salt and hydrogen. Key one there, the gas produced from this reaction is hydrogen. The gas produced, all of them will react with the period 3 and 4 metals react with acid to form salt and hydrogen. However, we should note that the types of salt produced depends on the acid used. For instance, if you are using HCl, that means you'll be producing chloride salts. If it is H2SO4, it will be producing sulfate salt. If it is a HNO3, it will be producing nitrate salt. So we should take note of that. And then another one is that when nitric acid reacts with aluminium, for instance, it will form a protective layer, Al2O3. So this protective layer makes aluminium unreactive towards HNO3, and therefore it can be stored in aluminium container. Take note of that. So let's look at the summary of what we have said so far. Let's look at the summary of what we have said so far. Number 1 is that metals are known to react with acid and resulting in the evolution of hydrogen gas. Only metals which lie above electrochemical or activity scale can involve hydrogen. What do we mean by that? Metals that are above hydrogen in the activity scale, in which most group period 3 and period 4 metals, all of them are above hydrogen, so they will liberate hydrogen with acid. Another thing we also need to take note of is the reaction of metal oxide with acid. Metal oxide will react with acid to produce salt and water. They react with acid to produce salt and water. Additionally, let's look at the reactions of Trioxocarbonate 4 with acid. The metal carbonates, especially of period 3 and 4, some of them will react with acid to give strong effervescence with evolution of carbon dioxide gas. Let's look at the nature of oxides and trioxocarbonates. All the metals, especially sodium, potassium, magnesium, and calcium, combine with oxygen to form metal oxide, which are soluble in water. The aqueous solution of metal oxide is basic, like we have said, and the basic nature is supported by the fact that when you dip it in litmus paper, it will change. When you dip it in litmus paper, red litmus paper, it change to blue. The aqueous solution oxide of AlO3 is amphoteric and therefore will not change the color of litmus paper. The aqueous solution of trioxocarbonate of metals are weakly basic in character and will change red litmus paper blue. Okay, so this is generally the summary of what we have mentioned so far. So let's quickly take few questions. Let's look at WAEC 2020 for it with the appropriate equation. You have to show the chemical changes that occur when piece of sodium metal is exposed to atmosphere for a long time. I will want you to attempt this question. Can we attempt this question, please? Okay, if you have known that, you should have gotten this. Sodium metal, like we have discussed, reacts with oxygen in the atmosphere to give sodium oxide. Of course, the sodium oxide reacts with atmospheric moisture to produce sodium hydroxide, and then the sodium hydroxide will also react with the carbon dioxide, atmospheric carbon dioxide, to produce sodium trioxocarbonate 4. And of course, sodium metal itself can also react with atmospheric moisture to produce sodium hydroxide and hydrogen gas, respectively. Please take note that the question specifically says with appropriate equation. So you are expected to put equation there. Yes, the WAEC expects you to use equation and nothing more. And then of course you have to show it like this. Actually, the question is 6 marks, 1.5 mark for each questions. So WAEC is expecting nothing more than this for that particular question. Okay, let's look at WAEC 2020. The question says you should write an equation to illustrate the amphoteric nature of aluminum oxide. Like we have said, aluminum oxide is amphoteric. It can react as an acid and as a base. That means that as a base, it will react with acid to produce aluminum chloride and H2O. Please take note that our choice of acid matters a lot. Like we have said, it forms a protective layer with HNO3. So it's much more important that we use HCl or even H2SO4 in this case. Okay, so it will react with an acid to produce ASL3 and water. Then it will also react with a base. It will react with a base to form a sodium aluminum oxide, which is a salt, and water. So these are some of the few questions we have been able to answer. So far, again, let me take us through the summary. The period 3 elements will react with oxygen. All of them will form oxide of different pH values, because some of them are acidic oxide, basic oxide, and of course amphoteric oxide. Okay, so please note that no period 3 and period 4 will form neutral oxide. Take note of that. And then the period 4 elements as well, especially the metals, will also react with oxygen to form their oxide as well. So again, they will react with acids to liberate hydrogen gas. They react with acids to liberate hydrogen gas. Take note of that. And of course, we have said that their trioxocarbonate 4 will combine with oxygen to form the metal oxide, which are soluble in water, basic in character. And of course, we also say that the aqueous solution of the trioxocarbonates of this metal are weakly basic in character and will change red to blue. Okay, so this is generally a summary of the lessons for today. Do well to take past questions relating to this topic we have mentioned, and of course ensure that you answer more questions on it and go through the lessons again. Thank you for being part of the class. Bye bye. See you in the next video.